Okay, in this next section, we're going to kind of do the exact opposite of what we did in section 4. If you remember section 4 from the other day, we were talking about how to do operations with polynomials, and we did talk about how to multiply polynomials. And we went over a couple different ways to do that. You can just use your FOIL method if it's two binomials. You can distribute if you need to, and I also showed you guys how to do the box method. Today we're going to talk about factoring polynomials, which is, like I said, the opposite of what we were doing with multiplying. So instead of trying to combine two different polynomials, we're actually trying to separate out the polynomials that they may be multiplied together to get the polynomial that we're working with. The reason why we do this is, especially when we're maybe looking for solutions of polynomials, like we want to know how much or like where the roots would be if I were looking at the graph. Factoring is one of the methods that we can use to help us do that. And factoring is probably one of the fastest methods, rather than like graphing or doing some of the other ones, other methods to figuring out what the solutions would be. So I'm going to kind of go over today a couple of different ways that you can factor polynomials. We'll talk about looking for the greatest common factor, or GCF for short. We'll talk about how to factor if you have to group things. And then we'll get into some of those special cases, kind of like what we did when we were multiplying. We talked at the very end of that section, we talked about how to multiply when you had like the sum or difference of two squares, or when you had two quantities, two binomials that were the exact same thing, and you were multiplying them or squaring them. We're going to kind of, again, look at special problems and how we can maybe find shortcuts to help us factor it quicker than maybe some of these other options that we have to do. Just kind of depending on the polynomial that they give you. Sometimes it works best to use a shortcut. Sometimes you have to do grouping. Sometimes there's maybe a faster method. It just really kind of depends on what they give you. And so after you kind of see the different ways to do it today, hopefully you'll be able to understand what to look for to know maybe how to approach the problem. So the first way we're going to talk about is figuring out what the GCF would be, or your greatest common factor. This is basically trying to figure out what's the biggest amount that you could divide all the terms by. So if I was finding GCF of just a couple of numbers, I would be trying to figure out what's the biggest number that I could divide into both of them. In this case, we're doing that with these polynomials. So what is the biggest term that we can take out? And this could be a number, it could be letters, it could be multiple things. So for this first one where it says 10x to the third minus 4x squared, I would first look at your numbers, 10 and 4. And I think 2 is the biggest number that I could divide both of those by. And then if I look at my letters, the first one has x to the third and the second one has x squared. You can always take out however many x's that works as long as it can come out of both terms. So in this case, the first one has 3, the second one has 2. So I can take at most 2 of them out because there's for sure 2 in all of them. So I'm just going to write x squared next to that 2. Now what you're going to write in parentheses after this is what would be left if you took out a 2x squared. So if I took 10 and I took a 2 out of it, like dividing, that would leave me with a 5. And if I have 3 x's right now, but I'm taking out 2, that would leave me with 1 x. So that first term would just become 5x. And then there's a minus sign here. And then 4 divided by 2 would just be 2. And I took out the x squareds. So there is no more x with this last term. So I'm just going to close my parentheses and we're good. Now, if you have something like the second example where you have terms that almost kind of already look like they're factored, you want to try to figure out, well, what do they have in common? And I'm noticing right away that the pieces inside the parentheses here already match. So this is actually probably my GCF, is that x minus 7. And so what I can do is, because they kind of already wrote those out separately, I can kind of write this out as 2 separate binomials. One of them is going to contain this GCF, so the x minus 7. So I'm just going to drop that down. And it doesn't really matter which set of parentheses you put it in. I'm just choosing to put it in the second one. But what goes in the first one? Well, if I take away the x minus 7s from both of these, you just take whatever's left from each side of the problem. So there's a 3x left on this side, and there's a plus 8. So that's going to get dropped down here. And honestly, some of you might look at that and you think, I feel like I've kind of seen that before, or maybe I've done something like that before, and you have. Last year when you guys were in Algebra 2, and we spent a lot of time working with the quadratic form last year in Algebra 2, you probably had to do a lot of factoring. And you probably did something like this, which is actually going to be the next method that we talk about. That's kind of alluding to this factoring by using a grouping method, where when you were trying to find things that looked the same, or you're able to take out the things that you know have in common, whatever's left inside of the parentheses, you wanted them to match. And that's kind of how we know that we're doing it right. Okay, so that kind of gets us into this next thing, which is when we're going to factor by grouping. So they're kind of showing you this example here where we start out with this polynomial 6x to the third plus 3x squared plus 2x plus 1. And if I look at this right now, it has 4 terms, okay? And if I look at all 4 terms, there's nothing that I can take out of everything. So yes, I could take a 1 out of all of it, but is that really going to do me any good? No, because it's not going to necessarily simplify this at all. So I'm going to not even think about that, but instead, I'm going to think about grouping these. Now, because there's an even number of terms, I'm just going to group the first 2 together. So I just put parentheses around those first 2, and then I put parentheses around the second 2. And you can kind of see that's what I have written down here is I'm grouping. And over here on the right-hand side, I'm just kind of showing you what I did here. So this is the associative property here. Because I'm grouping things together, how it makes sense to me, or how it's going to maybe work to my advantage to help me simplify this. So I'm grouping those terms together. And then I'm going to start to look at the individual parentheses. What do they have in common? Okay, so on this first one, out of my numbers 6 and 3, I can divide them both by a 3. And this is just like that problem that we started out with. I have x to the third and I have x squared. I'm going to take out an x squared because I know I can take out at least 2. Now, again, if I take things out, there's something that's left over. And so that's what's going to be stuck inside of my parentheses. So 6x to the third, if I take it out a 3 and an x squared, that leaves me with 2x. And this is something that I just want to point out. If you take out the entire term, like this is a 3x squared and I'm taking out a 3x squared, that does not mean that it's 0. Remember, anything divided by itself is always a 1. So if you take out the entire term, make sure that you have that plus 1 in there because it's kind of holding the place value of that piece. Then in the second set of parentheses where it said 2x plus 1, again, I'm looking for anything that I can take out, but I really don't think that there is anything. So I'm just going to bring down that 2x plus 1, but notice how I've put a 1 there. Okay, there's a reason why I wrote that in there for right now. I'm not always going to put that 1 in there. If I can't take anything out, or if it's already simplified, when you go to write it down in your parentheses, so you're already seeing down here how they got that 2x plus 1 is that's what was left over in the parentheses from my 2 terms. But this second set says 3x squared, which that makes sense. That comes from right here. And then plus 1. That is that plus 1 that I wrote in front of the parentheses. And I'm holding that place value again because sometimes what I'll see kids do is they'll just write 3x squared and they'll put a parentheses there and they'll stop. And that's not correct because even if you can't take anything out, like a 2, a 3, a 4, anything like that, you can still always take out a 1. And so that 1 is just going to have to kind of sit there. Just like when you divide something by itself, you have to have that 1 holding its place value. The same thing happens when you're factoring like this. So the 2x plus 1, that was what was left over in the parentheses. That gets put in one set. And then the pieces that are sitting out front, the 3x squared and that plus 1, that gets put in the second set. Now, we're also taking it a step further down here because you can see I'm not quite done, is that I'm going to actually figure out what my solutions are. And so that's why I said why we do factoring. It's to help us find the roots or the zeros of our equation here. So we're taking each of these things and we're setting them equal to 0. So you can kind of see how that works. They have a note over here that this is not a quadratic equation, okay, because my original polynomial started way back up here with a 6x to the third. So that's not quadratic. So this is actually going to have possibly 3 zeros here. But the first one that they do is they set 2x plus 1 equal to 0. They subtract the 1, and then they divide by 2. So we get one answer of negative 1/2, 0. And they're all going to be written like this when you find them, because you're figuring out where the graph crosses the x-axis at. And if it crosses the x-axis, it doesn't have a y value because it didn't go up or down. It just stayed on the axis. Now, this other case, we subtract 1, we divide by 3. What I would be trying to do here is square root this, but we haven't really spent any time yet this year talking about negative square roots. So for right now, we're saying that that's not possible. There are answers out there. Okay, so it's not to say that like this is like a no solution situation, but right now, because we haven't really talked at all about how to deal with square roots of negative numbers, which would lead us to imaginary numbers, we're going to just leave it right there at not possible. Okay, so I kind of walked through that whole thing. What I want you guys to do is take a couple minutes and I want you to try to do this problem by yourself. Okay, so here's what I would have done. I would have grouped the first two together, grouped the second two together, and then I would have tried to find things that could come out of the terms. So in the first set, I can take out an x squared, and that would leave me with a 5x plus 4. From the second set, you want to watch your signs on this one. You can take out a negative 2. And the reason why you want to take out a negative 2, this is kind of where my thought process is. I know that whatever I have left in the parentheses, I want it to match whatever's going to be written over here, because that lets me know that I factored it correctly. So because I was only able to take out an x squared, and that left me with this 5x plus 4, I know that I want a 5x plus 4 over here. Well, if I have a negative 2 taken out of a negative 10, that's going to get me to my positive 5x. Now, if I were to only take out a 2, then you should see that there's a negative 5x here, and then it would say negative 4 as well. But remember, if I'm taking out a negative 2, it's going to switch its sign, which is what I want. So something that I would recommend, especially if you got to that point and your signs didn't match, it's probably an easy fix of just take out the negative. So just watch that. I would say pretty much always when there's a minus sign here, you're probably going to be taking out the negative in order to get your parentheses to look the same. Okay, and then what I would have left is sitting out front is the x squared and the minus 2. And then the 5x plus 4 goes in the other set. Okay, and then I am going to take this a step further and I'm going to solve them. So I'm going to set x squared minus 2 equal to 0 and 5x plus 4 equal to 0. I'm going to add 2 on this first one, and so that becomes x squared equals 2, and then I would square root that. I can't really square root 2, so it's just going to be plus or minus the square root of 2. So there's one answer, and then over here I'm going to subtract 4. And then divide by 5. And I'm just going to leave that as a fraction, negative 4/5. But then you can see, back up at the beginning, we had an x to the third. There should be 3 answers that I can see. There's positive square root of 2, negative square root of 2, and then there's the negative 4/5. So there's actually 3 total answers there. Okay, for those ones, they all had 4 terms. And so we were able to kind of clearly see, we're going to split these in half, okay? Sometimes you're going to have trinomials, which would be things with 3 terms. And we're going to start out with the easier case, okay? So in this case, you're going to have a trinomial that looks like this form, x squared plus bx plus c. So what this means is that the number in front of your x squared is always going to be a 1. And then the b and the c are also going to be numbers. Okay, I'm saying this is the easiest case because there's a little bit of a shortcut that you can use to help you factor these. We'll talk next about what happens if that number in front of the x squared isn't a 1. So this only works if that number in front of the x squared is a 1. So what I can do here is when I look at something that has a 1 in front of the x squared, and most of the time they're not going to write that 1, they're just going to say x squared. You can kind of think about setting up like a little table or like a little chart, or even thinking to yourself a couple of things here. You're going to want to multiply to the last number in your trinomial. So in this first one, that's a 6. And then you're going to want to add to the number that's in the middle, which is a 7. So when I set it up, here's what I want you to think about. What are 2 numbers that multiply to 6 but would add to 7? So you start thinking about factors of 6. There's 1 and 6, and there's 2 and 3. Those numbers would multiply to 6, but which ones would add to 7? 1 times 6 is 6. 1 plus 6 is 7. So 6 and 1 are what I would call your magic numbers because they're going to be the ones that work. And then what I'm going to do is factor this by drawing out 2 sets of parentheses. You're basically going to take that x squared and split it, so each one gets an x. And then these numbers are going to be what follows. So you're going to have plus 1 and plus 6. The order doesn't matter. So you could have said x plus 6 and then x plus 1 if you wanted to. You'll want to watch your signs because sometimes they're not going to all be positive. Sometimes you'll have a positive and a negative, or they'll both be negative. And so you just want to make sure that you watch your signs and you get them correctly in your parentheses, and make sure that you have the right signs like when you're adding and subtracting the numbers together. So there's a couple more on this page, and they do start to flip the signs a little bit on you. There's 3 more here. I'm going to give you a couple of minutes. I want you to try to do the remaining 3. Okay, I'm going to run through these three here really quick. So I would have multiplied to a 9 and added to a -6. And so the numbers that do that are -3 times -3, -3 plus -3. And so I would write that as x minus 3 times x minus 3. Or some of you might be thinking I could have written it x minus 3 squared because it is the same quantity 2 times. For the next one, I would multiply to a -15 and I would add to a 2. So that'd be 5 times -3, 5 plus -3. So we'd have x plus 5, x minus 3. And the last one, I would multiply to a -15 and add to a -2. So it's going to be very similar to the last one, except our signs are going to flip. Once you get really comfortable with that, you don't need to write out your chart every single time. Some of you are going to be able to do that mentally and just know what the answer should be. The other thing I would say too is none of those we set equal to 0, but we could. We could start taking all those little individual pieces and setting them equal to 0 and getting our actual roots. Okay, but for right now, I'm just focusing on factoring. Now, like I said earlier, that only works if you have x squared. So there's not a number in front of the x squared. Let's talk about what happens if you do have a number in front of the x squared. So the form switches only a little bit in that instead of having one x squared or just x squared, there's going to be a number in front of the x squared. We talked about this when we went over just the basics of polynomials, but remember you're going to want things to be in descending order. So if it's not in descending order, we're going to need it to be that way. So for example, on this first one, I need to rewrite it so it says -3x squared plus 10x plus 8. So I'm just rewriting it. Now, the next thing that I would check, and this won't apply to all of them, but you're going to want to make sure that that first term is positive. So instead of a -3, I want it to be a +3. So what I'm going to do to fix that is I'm just going to take out a -1 out of all my terms for a minute, and I'll deal with that -1 later. But all that's going to do is just switch all the signs. So now my 3x squared is positive, but then the 10x and the 8 also switch signs. Then I'm going to look, are there any like terms? I don't see anything for this one. Now to figure out how to factor this, it's not as quick as those last ones were. Remember how we started out factoring today? We were using grouping. So we're going to do that again. Okay, we're going to basically use grouping here, but there's a little bit more of a process to that. You're going to have to multiply your a and your c terms. Your a would be the number in front of the x squared, and your c would be the number at the very end. So for this one, your a is a 3, and your c is a -8. And you can see that that's what I have written right there. 3 times -8. And so that becomes -24. Then you're going to kind of think about your t-chart. So you're going to want to now multiply to a -24, but you're still going to want to just use that middle number, that -10, as the number that you want to add to. Okay, so that's kind of taking step 5 and actually putting it in that chart. So I want to have two numbers that multiply to that -24. That's what I got my a and c to multiply to. And then I want it to still add to that -10. So that's very similar to what we were just doing with that kind of the shorter hand way. Okay, two numbers that would work for this would be -12 times 2, because -12 plus 2 would be -10. Now what we're going to do is rewrite my original polynomial, so rewriting this with these two numbers. So what I always say is you don't ever do anything to the first and the last term. So I'm going to write 3x squared. I'm going to leave a little space, and I'm going to write my -8. Okay, so I don't ever do anything to the first and last terms, but I'm going to rewrite that middle term, that -10x, with these two terms. So I'm going to put a -12x and a +2x. Again, the order that you put those in there does not matter. Also, just a reminder, we have that -1 still sitting out front, so I'm just going to write that. Now, I used brackets there because now that I have 4 terms on the inside, we're going to group. Okay, remember, this is what we started out our factoring method with, is grouping. So now I look at my individual terms here. So I still have this -1 floating out there. On this first set, I'm going to take out a 3 and an x, and that's going to leave me with x minus 4. Then remember, I want x minus 4 to show up in my second set of parentheses because that lets me know I'm doing this right. So to get an x minus 4 to show up, I need to take out a 2. Okay, and so then to kind of finish this off, I have this -1, and then I have 3x plus 2. Those are your terms sitting on the outside of the parentheses, and then x minus 4. Now, if I want to solve it, which is what they're showing you here on step 8, is you're setting these two pieces equal to 0, so they have that written out here. The -1 really is not going to impact anything. It's sitting out there. I took it out to make this problem a little bit easier for myself to deal with, okay? But it really is not going to impact anything. So at this point, I don't really even need to worry about the -1. I would need to know that it's there if I was working with the polynomial, but right now I'm just looking for the solution. So you can kind of see they set them equal to 0, and then they solved just like we've been what we did earlier. So I would say, honestly, out of all the things that you're going to factor, this is probably the most intense situation or the most intense case because there's just a lot of work that has to go into it. It's not as like easy as those last ones where you just kind of factor using the shortcut. You have to kind of know the process here. So I want you guys to go ahead and try to do that next one by yourself. Okay, I'm going to kind of start working through this. So my A is 14, my B term is -35, and my C term is 14. So I'm going to take A times C. So that's going to be 196. So I want to find two numbers that will multiply to 196 and will add to a -35. Okay, there's no shame in using a calculator here. Like if you need to use a calculator to try to find your factors, that's fine. I came up with -28 and a -7 that will work. Then I'm going to rewrite it. So 14x squared goes first. Then it doesn't matter the order that you put these terms in. So I'm going to do -28x minus 7x and then plus 14. Now we're going to group. I'm going to take out a 14x from the first set, which would leave me with x minus 2. And then I'm going to take out the -7. Remember we said anytime that there's a negative sign there, you're probably going to take it out. So I'm going to take out -7, and I get x minus 2. So then I would write that as 14x minus 7 and x minus 2. And then the last thing that we'll do here is just set these both equal to 0. So I would get 14x equals 7. If I divide by 14 and I reduce that, it goes down to a half. So there's one answer. And then over here, it would be x equals 2. Okay. On the top of the next page, if you remember when we factored, or not factored, but when we were talking about just polynomials, I kind of talked about how if you can recognize some of those shortcuts, some of those patterns that we talked about, it's going to be really helpful because we're going to be able to use some of those patterns to help us shortcut some of these processes. So when you have something that looks like these two, where instead of seeing like 3 terms, like what we're used to seeing, or even like 4 terms where you want to automatically try to group them together, these ones only have 2. Okay, and we're talking about the difference of 2 squares here. So difference means subtraction, so you want there to be a minus sign. And squares means that the numbers that you're working with should both be able to be square rooted. So they're perfect squares. Remember those perfect square numbers that we talked about last week? The 4, 9, 16, 25, 36. Those numbers that we created that perfect squares list with. So when I look at this first one, those are going to be the things I look for. Is there a minus sign? Yes. Okay, so that's the first thing that you need. Second thing then is, can I square root these two numbers? Can I square root the 9x squared and can I square root the 4? Yes, I can. Okay, it's the square root of the 9x squared would be a 3x and the square root of 4 would be a 2. So to write my answer, you're going to take those terms, 3x and a 2. You're going to put it in 2 different parentheses here. One's going to get a plus sign, one's going to get a minus sign. If you think back to when we actually multiplied things, we talked about this special case. Those inner terms are going to always be the same and opposite, so they're going to cancel. That's why I kind of don't need them to show up here in my answer. Okay, and so then when I actually follow that shortcut, I get right back to where I was, 9x squared minus 4. Now, if you look at the second one, yes, the 4x squared and the 25 are perfect squares. I can square root them nicely. However, do you guys have a minus sign here? No, you don't. So this is not the difference of 2 squares. So we're going to say not factorable. It has to be a minus sign in order to use that rule. If it's not, then you can't do it.